Alright, the last part of the lecture that I want to cover is known as Open Newton Cotes method. The reason we have Open Newton Cotes method is because sometimes we are asked to do an integral over your limits a to b, but the data points that you have do not cover the entire span from a to b. So for example, let's say you have x and you have fx. Okay, so let's say you only have one point, which I'll call x0, and for x0 you have the corresponding value of f0. Okay, so you only have one point x and the corresponding one value of f, but you're asked to do an integral from a to b like this. Okay, or let me be more consistent with the later slides. Let's say this is x1 and you're asked to do an integral from x0 to x2 of fx dx. So how do you do this integral? Because if you want to use trapezoidal rule, you would need to know the value of f at x0 and x2, but this is not known to you. You're only given one single point x and one single point f, so this should have been f1. Okay, so this is where Newton Cotes method comes in. With closed Newton Cotes method, what we are essentially doing is we are fitting a curve to the set of data points that we have, and whenever we are fitting a curve, we are actually carrying out interpolation. But over here we cannot do interpolation because we have less amount of data to cover the entire span. So what we do is we do extrapolation. Alright, so let's say fx is the function that you want to integrate, and let's say fx has a curve that looks like this. Alright, so it has to pass through the second point. Let's say this is your fx, but you only know one single point f. So the easiest way to extrapolate is to assume a zero order extrapolation. A zero order extrapolation basically means that you're going to extend this to the left and you're going to extend this to the right, and then you're going to say that the value of f at x0 is the same as f1, the value of f at x2 is also the same as f1, and in this case, let's say distance between x1 to x0 and x2 is the same h. So if you do extrapolation to the left and you do extrapolation to the right, we can say that the area under the curve can be approximated by the area of this rectangle here. So this can be approximated as 2 times h times f at x1, and we know what is this because that point is given to you. So this is the idea behind Open Newton Cotes method. Instead of doing interpolation, we do extrapolation. Alright, so in the case where we have one single point and we are asked to do the integral over two segments, with this is segment 1 and this is segment 2, we can extend the value of x1 to the left and to the right, and we end up with this formula over here. Okay, what if we know a higher number of points? Alright, let's say if we have something like this. So right now, let's say that you are given 2 points, and those 2 points are x1 and x2, and for this x1 and x2 you will have the corresponding values of f1 and f2, but right now the integral wants you to do it for x0 to x3. So x0 and x3 are not known to you. So how do you do this? Because you have 2 points, what you can do is you can draw a straight line to connect these 2 points, and then once you have this straight line, you're going to extend this to x1 to find out what this point is, and you're going to extend to x3 to find out what this point, and you're going to calculate the area under this shape over here. Okay, so essentially what we are doing is we're extrapolating linearly to the left, we are extrapolating linearly to the right, and then we are going to calculate the area under this straight line over here. So this is essentially a linear or first order extrapolation, and you will be able to show that the formula to calculate the area is given by 3/2h times f1 plus f2. So for the case where you have one single point like this would be your formula. If you have 2 points, or in other words if you have 3 sections 1, 2 and 3, then the formula would be given by this. So the same extension can be done for the case where you have 3 points, 4 points, 5 points and so on. So a table is prepared for you here for you to see how these formulas relate to the number of segments that you have. If you have 2 segments I mean one node, just like this. If you have 1 point but you have 2 segments, then the formula to calculate the area or the integral would be given by this 2h times f1, which I've shown to you earlier. If you have 3 segments, that would mean that you would have 2 points. So 1 point, 2 point, but you have 3 segments over here. And because you have 3 segments, this would be the formula. So the same, but if you extend this thing to 4 segments and 5 segments, then these are the 2 formulas that you have, and this would be the corresponding truncation error. So open methods allow you to do integral if you do not have sufficient data points to cover the entire range. But because open methods are based on extrapolation, they would basically have higher errors compared to closed Newton Cotes method.